Today I'm going to talking about the LeetCode question 34. Find the first and the last position of element in the sorted array. Okay, so this is a problem. So given an array of integer names, this one is sorted, okay, and then find the starting and ending position of a given target value. If target is not found in the array, return -1. So that means that this is the first position and the second position both return -1. So and here you must writing an algorithm with O log n runtime. So whenever we saw the O log n, that means that we can think about the binary search. So this problem is a binary search problem. Okay, let's start from here. So it's binary search problem. Okay, and then let's see here. Let's see the constraints here. This one is a non-decreasing array. That means it's a increasing array. Okay, so let's see here, increasing array. Yeah, here. Okay, let's give an example to solve this problem because we are looking for the first and the last position. So we probably have to run twice the log n because we need to actually run. We need to actually run once looking for search for the first position of the element, and then we search another one, the red one. So here is the question. Let's copy paste here. Here's the one. Okay, so before I give an example, okay, before I give an example, I will introduce some do some introduction of the binary search knowledge. 1 second. Let me do this. Okay. Okay, so whenever we solve the binary search problem, so what's binary search? So binary search is an algorithm that divides the search space by 2 after every comparison. Okay, so the binary search should be considered when every time you need to search for an index or element in a collection. So in our question, we are searching for the first position and the last position. Actually, we are searching 2 index. Okay, so that's why we use the 2 binary searches. The first time we can use once for searching for the first position, the index of a first position, and another binary search for the the index of last position. Okay, that's basically the problem. So if the collection is unsorted, we can always sort it first before applying binary search. So in the given problem, it's already sorted. Okay, it's a non-decreasing order. That means it's increasing order. So generally, when we saw the binary search, the problem we have to kind of pay attention about 3 parts. Okay, so first we need to do pre-processing. Pre-processing is like a sorted. If the collection is unsorted, okay, you can actually always clarify from the interviewer if the array or the list is sorted or not. And then we do the binary search using a loop or recursion to divide the search space in half after each comparison. And then the post-processing is determine variable candidate in the remaining space. Okay, so here is the template. We have 3 templates. You can get this from some university's website, right? So it's very popular. So let's talk about the first template, the first template. So we can see the left equals to 0, the right is the length minus 1, and then here is a while loop. A while loop, we have left smaller equals to right. So that means that we will stop when the right plus 1 equals to left. So in this way, that is like once the left, so even the left and equals to the right, we still run this loop. That means that we only over the loop once the left cross the right. That means the position of right is here, position of left is here. So yeah. Okay, so and then when we're trying to return, we can see here if the numbers middle smaller than target, and then we update the left is middle plus 1, and this one middle minus 1. Okay, so in this case, we actually iterate every single element of the array or list or collection, whatever, because of the here. Okay, there's no more candidate in this case. Okay, and then let's check the template 2. The template 2 here is right equals to length, and then so this case actually see when we update the left, we only update the left is the leftmost plus the middle plus 1, the right we still keep this. In this case, we have one more candidate left. We need to do post processing. Okay, and then when left and right, left equals to right, the condition stopped. And this one is template 3. In the template 3, we iterate from 0 to the last element of the array, and then we can check here. The condition is left plus 1 smaller than right. That means here is left, here is right. When they are neighbors, the left plus 1 equals to right is not smaller than right. Is gonna be kind of is out of this while loop. That means the left, the stop condition of the while loop is when the left pointer and the right pointer are neighbors. So they are not iterate the left and the right, the two candidates. So there's two more candidates left. Okay, we have to do the post processing. Okay, so when we're gonna use the template number 1, the template 1, so when the search condition we are talking about here can be determined without a comparison to the elements neighbors or use a specific element around it. So whenever like let's looking for a target or unique target in an array, so we can use this method. Okay, it can iterate everything, and then the template 2. So when the search condition need to access elements immediate right neighbors, so we're gonna use the template 2, and the template 3. The search condition here needs to access elements immediate left and right neighbors, so we use this one. Okay, yeah. This one is very efficient also sometimes. Yeah, depends. Okay. So in this is the basic kind of knowledge of the binary search. Okay, so let's go back to this question. Okay, that's kind of a knowledge. I'm just trying to do an introduction of that. So let's give this example. This our example. So let's 1 second. Let's 1 second. How to do this? Okay. Yeah. Okay. So first, at the beginning, the left. Okay, at the beginning, the left is here. Okay, 1 second. 1 second. I'm trying to, yeah, this way, in this way. Okay, this is the left, and then this one is right. Okay, the first one. Okay, let's notice this one. The index 0, 1, 2, 3, 4, 5. Okay, this 1, 2, 3, 4, 5. We are looking for 3 and 2. We are looking for 3 and 2. This is what we are looking for. So, okay, so let's start from here. So this one is the left, this one is the right, and then the middle for this example is M. And then, okay, so it's M. And then we update our right to here. We update our right to here. No, sorry about that. So because the middle actually smaller than 8, so we update left to the middle. Okay, we after to the left to the middle. That's the next iteration, and right is here. And then we can find that the middle is here. Okay, the middle is here. The middle now is 8. Okay, so middle is 8. So in this case, should we update left or right? Because it depends. So if we are looking for the, let's say, if we are looking for the leftmost, we are looking for the 3. If we are looking for the 3, okay? If we are looking for the 3, this one. So in this case, we are trying to update our right pointer to as much as possible to the left. So, and then in this case, left still here, our right is here. We are updating our right. Okay, so this is in case. And then because our whiles the stop the search condition the search condition for our while loop is L plus 1 smaller than right. So when they are neighbors, okay, so this kind of is stopped. So yeah, this is our while loop, and then we check left or right which one equals. So we check left. If left equals to the target, then we return the index of the left. But if not, then we return the right one. The index of the right is what we're looking for. Okay, so let's find that's the way how we find the kind of the left. Okay, 1 second. The first position of target. So let's find the right position of the target. Okay, so first we have left. And then this one is right. And then here's M. And then because we are looking for 8, right? So we still update the L now. And then the right is here. And then the middle is M. Okay, how do we update? This is left, this right, this middle. So in this case, middle equals to the target. So which one we should update? Because we are looking for this index. So we are trying to update left in this case. Okay, so the next one is gonna be left is here and right is here. Okay, M is here. Okay, and then because 8 equals to the target, and then next time we're gonna update left again. This right. Okay, now our while loop, the search condition is L plus 1 smaller than right. Okay, and then our loop we kind of we out of the while loop now. The while loop. Okay, yeah. and then we return the rightmost the 4. So we check the left and right. So because we are looking for the right, so first we check if right equals to the target. No, then we return this one. Okay, let's do the code of this problem. Let's start coding. So what are we gonna do first? The base case. No, the corner case. Sorry about that. So we need to check if this equals to none or no. So name.length equals to 0. In this way, what we're gonna do, return new int -1 -1. And then we're gonna give the we're gonna define the variable we're going to use. Okay, we will do this. Okay, so after we do this one, so what are we going to do? Let's actually, we are going to find the left, the first position of the target, the left, the kind of the index of the left. So we're going to use this one. We're gonna write it down in the target. Okay, this one here, and then this is the right. We are looking for the right. Okay, this one. Oh no. And then here, what we do? We search the last, and then next target. Okay, and then we return the new int, return the new int left and right. Okay, and then what are we going to do? What are we going to do? This is a search range. Okay, let's define the method of the return of the method here is int. Okay, because we are looking for we are searching for the position, the index of the first and last position. So let's do the first position equals to this one names and int target. Okay, this target. Okay, this left equals to 0 and int right equals to names the length -1. Okay, while left +1 smaller than right. The stop condition we just talked about here, right? The while loop search condition is like this, and then there will be neighbors, and they will stop at the neighbors. Okay, we just talked a lot about this part. Okay, yeah, and then inside the loop we're gonna have integer. We have middle equals to left plus right left by 2. So we do this way because we want to avoid overflow here, right? So that's why we do the left plus or right minus the left by 2. Okay, now it's much like and then we check names because we are looking for the first position. So we are trying to update at most of at the right pointer, the right position, updated to the left. So what are we gonna do? If greater equals to target, greater or equals to target, and then the right equals to middle. Otherwise, is else. We're gonna do left equals to middle. Okay, so pay attention about here because we are looking for the first position. So that means that when the middle equals to target in this way, we're gonna update our right. We're gonna update our right pointer. Do you remember? Do you remember we are talking about the case, right? So we are trying to like update about that. Okay. Okay. This is a while loop. Okay. So after the while loop, what are we going to do? We're going to name this left equals to target. So we're gonna return the left. Yeah, we need to return the left. So if we will check the left if it equals to the right or not, equals to the target or not. If it equals to the target, then we return the left. Otherwise, we're gonna do. Otherwise, we're gonna return. We're gonna return the names right if equals to target. If equal to the target, and then we return right. Otherwise, we return -1. We return -1. Okay. Yeah, this is the one. Okay, let's check another one. Let's write another function of the, also here the return also is int. Okay, search the last. Okay, let's do the search the last. And this array names and the int target. Okay, int target. Okay. So what we okay, so so the binary search, this part is the same as the one same as the first this part is the same as the search the first position of that one. So when we're looking for that, so we just actually do the same. Okay, and then the while loop. The while loop, the condition is the same as the one we just there's while, and then so what are we gonna do? We're gonna define the left. We are trying to avoid the overflow, and then we do this, and then we do if names, if names middle smaller or equals to target, smaller or equals to target. Yeah, because here we with the smaller, because we are updating our left. We are looking for the right, the rightmost, so we updated the left. Middle. And then we check if the rate equals to target. If it equals target, we return rate. Otherwise, we return. Otherwise, we check if the left equals to the target. If it equals to, then we return left. Otherwise, we return -1. Okay, let's check. Let's run the code. Let's run the code. Mm-hmm. 47. Oh, sorry about that. Here, we need to actually, what are we gonna do? We will do this. Okay, let's run again. Okay, it's accept. Okay, so the time complexity for this problem, because we did twice binary search, the okay, so the time complexity for this problem, because we did twice binary search, is 2 times big O log n. And then the space complexity is big O, sorry, that's Q, big O n, because we don't use extra space. Okay, here is big O, big O, and then actually this one also is log n. Okay, yeah, let's submit. Okay, see, we running time is 0 faster than 100% of Java Online submitting. Okay, the rank is 100%. Okay, thank you for watching. I'll see you next question.